Like I said a few minutes ago, I'm a long-time listener and a first-time caller, so this is my first presentation, and it's just beware. Anyways, my name is James Klinger. I'm an ACI member. I'm on committee ACI 318 sub A. ACI 117 tolerances. 134 constructability, and I'm also on the construction liaison committee. I am currently the hotline operator for ASCC. I'm the guy that gets the phone calls at 3, 4 o'clock in the morning, and as I said, I'm a third-year apprentice to Bruce Supernaut. Thank you, Bev, for your comments. It's an honor to be introduced and have these comments from an ACI honorary member. So very happy to see that. Today's lineup, well, I made a prepared statement. So this is a chaotic industry that we're all in. It's constantly changing. You know, one small change over here can have a ripple effect among designers, suppliers, and of course, concrete contractors over there. Bruce is one of those rare talents who can see the industry from many vantage points. He was a professor, owned a test agency, he was a structural engineer, a forensic engineer, an expert witness, stand-up comic, author, and concrete contractor. We all know that concrete is a natural product. It shrinks, cracks, bends, curls, and even explodes. Why is that? Are there workarounds? How can we find lessons learned? So today's lineup features a lot of speakers who will be able to explain how Bruce has affected the industry probably a lot better than I'm going to be doing. So we all know that concrete moves and behaves in mysterious ways, and so do careers in the concrete industry. For me, it's all been about luck. I learned early on that you always have to try to position yourself to get lucky. And the harder you work, the luckier you get. I started out with Miller & Long Company. I worked at KCE Structural Engineers. I worked for Martin Middlebrook and Louis here in San Francisco, and then for Conco, a local contractor. Each step of the way, I was lucky to have people that I was working for that had great situational awareness and excellent mentorships. So the only regret I have, and I would tell that to any of the young people here today or the people listening at home or at the ships at sea or whatever, my only regret is not having the wherewithal or the foresight to get involved with ACI earlier in my career. Everything else, it was all good, but that to me is of vital importance to somebody's career. To get involved with ACI and also ASCC. Luck plus a well-stocked library. This is one of my favorite sites right here. It's the 5-volume set going back many, many years, and I spent many hours telling people, hey, I don't want to go to lunch today. I'm going to sit at my desk and just grab one of these books and start thumbing through it. And boy, was that a good decision. Lucky again, World of Concrete, 2017. I come walking into my first World of Concrete, and there's the ASCC booth, there's the classic Hawaiian shirt, and I made a beeline over, introduced myself to Bruce and said, you know, you don't know me, we never met, but you have helped me out of so many dicey situations in job site trailer meetings. It's just unbelievable. So I just want to shake your hands and say thank you very much for what you've done for me. And then I'm not sure how it happened, but I ended up working for Bruce. And I worked for the ASCC Dream Team. You had Bruce, you had Ward Balish, and Beverly. And what a ride that's been. That's the best in the business right there. So for me, that was more luck. Rules of success in the concrete business: be safe, have fun, make money, and then keep the money that you just got done making. We have to realize that concrete's a heavy, natural product. This is a tough business we're in. Look again, it ain't always what you think. You always have to be the best you can be in service to the owner. Collaboration is the key to it all, and I know Kerry's going to be talking to that. and then challenge the system, which is something that you always should do. Safety first. You don't ever want to be in this scenario in a concrete pour. As you can see, there's guys leaning too far over that handrail there. Have fun. Bruce always makes sure that at Christmas time we have enough Christmas cards and Christmas ornaments to go around. Sometimes humor is at my expense from Bruce. Here I am. I'm in the hospital. I've got a spinal cord injury. I can't walk from the waist down. The handsome face that you see now is covered in blood and stitches. And so what does Bruce do? I get a huge stuffed pig and a safety manual for bicycle safety. So thank you very much, Bruce. It's a tough business. You don't ever know who you're going to run into during a 10,000-yard mat pour, especially in downtown San Francisco. We're a city here of inclusivity and diversity, and as you can see, all are welcome on concrete pours. Concrete is a natural product. You've got coarse aggregates, so we're recycling rocks. You've got fine aggregate, so we're recycling smaller rocks. Water, we recycle that. And then you have cement, which is some of that is recycled as well. So it's a natural product, quite simple. You can see in the supply chain is really basically there's your constituents right there. All that's missing is the water, but I think on that day it was about ready to rain. So, you don't ever want to be at the end of the concrete pump and find out what the constituents are by grabbing a handful and having it look like that. That's just rock, sand, water, and a little cement right there. This is from an actual hotline call. Had a pretty well-off guy here in the Bay Area hired one of our contractors to build out his basement. And this was the first wall pour. And of course, the owner shows up the morning that the guys strip, and he sees this. And so the call I get is, hey, the owner wants to know why do I have this blue wall? He wants me to take it out. And so we had to calm them down and say, look, concrete's a natural product. This has slag in it. The first day or two, you might see that on your wall, but it's going to go away. So just relax. It's called the greening effect. It's normal and temporary with this natural product. For the steel guys, their design equations are pretty much all based on calculus. So here is the formula for lateral torsional buckling. It's a second order differential equation, and that's something that they can do. So almost all of their equations are based on calculus. It's not that way with concrete. This was back in the days of slide rules and IBM punch cards when I was in school. Now all I can really think of is you got shear moment and a senior moment at my age. But what you got here is you take the dead load and you overestimate it by 40%. As an estimator, you try that, you get fired. You take the live load and you overestimate that by 70%. And then you have some factor U, which is going to be the strength of the building, which then you usually fudge that down by 15% or whatever the fee factor is nowadays, adjusted for inflation. I don't know, but one of the things that attracted me to ASCC was that they always challenge the system, look out for the contractor, and we help each other out. And another important thing is that we leave the party affiliation at the door when we come into a meeting there. There are times where there have been other contractors here in the Bay Area that we are fierce competitors with, but I can call them at any time, unless it's a job we're bidding on, of course, and we can discuss things, and we freely help each other out. That's one of the things we do, is we share with others. And that's that one. As contractors, we usually have to help those less fortunate than us. We often question, where is the engineering judgment? And so we like to help our fellow engineers and suppliers understand that one. This is a case in the code of engineering judgment. Over on the left-hand side is the actual code. So whenever you have a construction joint, it's in the middle third of the span where your shear is lowest. That's just the way it's always been. If you look at the commentary, you see that it says, well, it's not the case though with post-tension stuff, and that's because it's got a long history of satisfactory performance, therefore it's not applicable to PT. In other words, it works. We have collaboration with ACI, probably one of the better books around for, it's less than $100, I think. Extremely valuable. It's got all of the legal, quality, and ASCC position statements in there. That was largely from Bruce and his contribution to that. Here's a study in two classics, Bruce style. This is a building that maybe some of us will see here in the fall. It was a high-rise steel building, and they topped it out. They ran the building skin, which was plate glass windows, and then all of a sudden the windows started falling out, crashing into the street, and they were replaced with plywood. And so that building became known as the Plywood Palace. And then, upon completion, it's a tall building like this. So there was a big investigation, lawyers, non-disclosure agreements. Nobody was allowed to talk about it. What was going on? Was it the windows were failing? And so on. And they finally came up with some kind of an idea. But then somebody said, well, wait just a minute, guys. There's something else going on here. And Bruce would say, hey, I don't do windows. Look again. And it turned out that the building was actually in danger of collapsing under wind load. And you say, okay, I get that. It's a tall building like this. If you ever tried to carry a piece of plywood in the wind, you'll see that the wind is something to be reckoned with. Only in this case, it wasn't what you thought. That building wasn't in danger of failing this way. It was in danger of failing that way. So a lesson learned from Bruce, it's not always what you think. Always take a second look. A good way to cure claustrophobia, in other words, is you always got to think outside the box. Here's another study in two classics. So imagine Bruce sending me this picture saying, I've got this picture here of some exposed concrete. What do you think? And I'm looking at that, and I'm thinking, well, geez, it's exposed concrete. It could have been patched a little bit. The lines are nice and straight. You've got some point loads in the mid-spans here. I don't see a whole lot of deflection going on. Yeah, Bruce, looks okay. So let's take a look inside. Say, man, look at that. The formwork guy, he's got nice, his lines are all nice and planned. You see a little bit of patching, but not much. The guy that designed this was insistent on exposed concrete, natural concrete, and he would berate the workers when they stripped because they were starting to patch the concrete. But Bruce says, no, look again. What do you see? And I'm saying, well, geez, I see this building there, Bruce. And he says, no, down here. Look at that. Okay, look at this. This is beautiful. It's a classic beauty. Textbook curling, crack field pattern. All these corners here have become a cantilever and popped. All four corners. And then here, almost a perfect circle right here. You're never going to see a better example of curling in your life. So here's an example of curling. This was from Walvis Bay, Namibia. So there you've got all your panels. You have, several things going on here. You've got curling, and then you've got bird baths, and so on. And I thought, my God, what a magnificent picture. So I got in touch with the fellow. His name is Rod Rankin. He's an engineer in South Africa. And I asked him if I could use this slide in my presentation. And well, it's for the same reason. So Rod emails me back and he says, by the way, send my best wishes to Bruce. I've never met him in person, but I've been an avid reader of his articles on concrete ground slabs for many years. So there's fan mail from South Africa for Bruce. This is a hotel down in south of the border for surfers. When I look at that, I'm thinking in the fall, ACI Excellence Award, just beautiful concrete work, just phenomenal. And the formwork, just the sheer beauty of this is just staggering. You look again, and what do you see? You got a little bit of form leakage up here. This may not actually be ADA, but it's a natural product. This is just up the street, 1355 Market Street, built in 1937, board form concrete. You see there are 3 happy guys. 2 of them just got rehired. They were fired when Elon bought Twitter. They're rehired, and there's the richest man and the richest owner in the world. Look at all the buildings he owns. What do you see? Up in here, you got a little bit of honeycomb action going on. Maybe down here, a little form leakage. So the moral of this story is that concrete's a natural product. It's quite beautiful, and some people might call those defects. I'm not sure that owners really worry about it that much. Obviously, this one doesn't. ACI 301, we quote that quite often. I call it the Lombardi rule. That is for the architects and the reviewers of mock-ups that like to get out their magnifying glass. Fellows, not so fast. This has got to be viewed at 20 feet in daylight, hence the run to daylight of Vince Lombardi. So we quote that rule quite often to get people to understand that this is a natural product. It's going to have a divot here and there. Get back 20 feet. Collaboration, this is from Bruce's library, his first notes for early position statements. And he's able to get people in the design offices and in the field all on the same page across all different trades. And a lot of that work was eventually turned into position statements, articles in Concrete International, or Concrete Q&A, and so on. One of the most notable collaboration items that Bruce was responsible for was getting all of the flooring contractors and follow-on contractors on the same page. Everybody knows here that's a contractor. You pour a slab in January, and then in November you're going to get that phone call. Hey guys, the follow-on guy's here to put his flooring down, and he's not accepting your substrate. And you say, well, geez, it's this is something where we can't control what happens to that slab 9 months after we've placed it. By rules, by ACI 117, the testing for flatness and the quality of our work has to happen within 72 hours. So don't be calling me 9 months later. Finally, it dawned on everybody, thanks to Bruce getting everybody together, that any repairs that are needed for a floor surface really is something that the owner should carry an allowance for, because the concrete guy, we can't control when the flooring contractor is going to come in. And it's not the flooring guy's issue either. He's showing up expecting a certain quality floor. So thanks to Bruce, he got all of these trades to get together and stamp this position statement and say, you know what, this is a legitimate allowance item for the owner to carry. Thanks to Bruce and the tolerance book that he wrote with Ward, he's the guy, the only one that will show you that the concrete guy can build his core perfectly. The steel guy can erect his steel according to his tolerances perfectly, and the two won't marry up. There's another issue with anchor bolt tolerances, and Bruce got together with the AISC and ACI, sat everybody down, and came to an agreement on what constitutes reasonable tolerances for anchor bolts. So another example of collaboration among trades and disciplines. You know, who else but Bruce to run the whole gamut from cores to, you know, to submerged piers. Quite a varied repertoire there. Here's an actual case study. We had a new technology come out, the laser scanner. And the laser scanner came out, people started buying them, and then one day I got this drawing. And the letter from the GC said, you know what, you poured this slab a long time ago, we just had somebody come out and scan it, now you owe us cash, and we're going to go ahead and deduct that from your retention. And at that time, because of that emerging technology, Bruce had the foresight to say, wait a minute, if this is going to be used to judge our quality of our work at our tolerances, then we need to get ACI 117 involved, which now, of course, has the 117 sub-L subcommittee for laser scanning, which Leo is now the chairman. So we did a study in Walnut Creek. We had 8 teams of different laser manufacturers. We had a freshly poured slab here, poured the day before, and another slab down here that was several months old. And we had the teams alternate between each slab over a 2-day period. That study and then one other became a series of articles in Concrete International magazine that let everybody know what the technology is and how best to deal with that. Also, the presentation of the heat map, we just had Leo prepare a protocol for how to properly present information to somebody. If you're going to tell them that their quality of their slab is good or bad, you should at least have some basic information in there. So this was in Concrete International magazine, and then for reporting F numbers, there's also a protocol that should be followed. You just don't send somebody a heat map and tell them that they owe you cash. From that study came this picture, which is we call the Magnificent Seven. If you do a reverse Google image search of this picture, you're going to come up with like 90 hits of different companies that have used that picture in their advertisements. So you have Andy Huntley, me, Bruce, Eric Peterson of WebCore, Rex Donahue, ACI, and Cutter Shea and Will Paul. So these guys here founded that study. Here's another thing, concrete's a natural product. When you read architectural drawings, you always want to look at the deflected ceiling plan to see what's planned there. For steel guys, again, it's pretty simple. You have a point load, and it's pretty easy to see. If the length is 1 and the deflection is 1, if the length is 2, you double the span. The deflection is now 8. That's 2 to the cube. And you could think about that if 2 guys are standing with a number 4 bar 20 feet apart and it deflects an inch, okay. If you double that span and they're 40 feet apart, the deflection is going to be 8 times that, or 8 inches, and that makes sense. Not so with concrete. With concrete, there's in 117L, there's expected deflections over time, and as you can see there, deflections are estimated within a range of 20 to 40% accuracy. Why? Concrete's a natural product, not as predictable as steel. Time? Okay. Okay, we have Kerry Kopczynski. He'll be speaking to you here pretty soon about collaboration. These two president's memos here to me were very significant because it's the first time I've really seen from the design side somebody talking about constructability and trying to find out the business from the contracting side. So that was something that I really enjoyed seeing. Right now in 117, you have collaboration. Meetings are mandatory, but you don't have to bring the engineer or the owner. Now in 301, if it's specified, you can get the engineer and the owner involved. But then the AIA documents kind of prevents that because they don't want the contractor speaking directly with a designer. So, and that as a result of collaboration like that, you see special notes to owner on structural engineers' drawings now where it says, hey, Mr. Owner, concrete's a natural product, it cracks, it moves. So I'm going to have to blaze through these. The last one here is Bruce wrote an article, where to place the vapor retarder. I get a call on the hotline, and the guy says, hey, I'm not an ASCC member, but I need to know, are you sure that that's right? And I said, well, yeah, Bruce wrote it, and pretty much trust him. And he says, well, wait a minute. What you're showing me here, if I do that, you're going to guarantee that my work is going to be good. I said, yeah, sure. He's got a license. I'll guarantee you against his license that this is the way to do it right here. And the guy says, well, good, because I'm going to send you the bill, because I did just what he showed me right there. So Bruce, thanks a lot. You've been kicking ass and leaving footprints for many years, and it's been a pleasure working for you. So.